Hey everyone, and welcome to another episode of the Lazy Programmer Show. In this video, we are going to revisit TensorFlow 2. As you may have heard, my TensorFlow 2 course, which was released approximately this time last year, has become the biggest TensorFlow 2 course on Udemy. Since then, I've created an analogous course for PyTorch. Now obviously, deep learning is still deep learning, so they all cover the same topics, like ANNs, CNNs, and RNNs, just with different libraries. From your perspective, you should choose the course that covers the library that you care about, whether that's for work or just personal interest. So the reason I wanted to make this video is, now that I've had a year to work with TensorFlow 2, what are my thoughts now? How does it compare with PyTorch? How does it compare with even newer deep learning libraries such as JAX? And by the way, JAX was made by Google, so don't assume that by using TensorFlow, you are using what Google's using. Before we continue on with this lecture, just a short reminder that we are already 2 weeks into the month-long VIP sale of my latest courses on PyTorch and financial engineering. After releasing the leading TensorFlow 2 course on Udemy, I thought it would be an excellent idea to teach PyTorch 2, the next up-and-coming major deep learning library. In fact, many indicators suggest that this era is already here. Companies like OpenAI and Apple have switched to PyTorch, and Facebook, who is now the primary developer of PyTorch, obviously uses it as well to serve their billions of users. Today, most research papers are implemented in PyTorch, so I think the evidence is clear where the field of deep learning is going. Use the link in the description below to get your copy of the VIP version of PyTorch today. Remember that the VIP version contains entire sections of material that will not be available in the non-VIP version of the course. This course contains everything from the basics like ANNs, CNNs, and RNNs, all the way up to transfer learning, recommender systems, GANs, NLP, facial recognition, and building a stock trading bot using deep Q-learning. My financial engineering course is my newest and most exciting course so far. Most of my courses have taught you machine learning from a very broad perspective. This meant that we could never take a deep dive into any particular domain, like finance, biology, or any other specialized niche. Well, I've decided to break that tradition and take you into the fascinating world of finance. Many beginners hear about machine learning, and the first thing they think is, it would be a great idea to build an LSTM that can predict stocks. Believe me, you are not the first person who has thought of this, and many marketers out there are capitalizing on your ignorance. In this course, you will learn what finance is really about in terms of the core topics that all financial engineers must learn. These include how to model stock returns statistically, time series analysis and forecasting, and portfolio optimization. The VIP version of this course will introduce you to algorithmic trading. This will culminate in the application of Q-learning, which is an advanced technique that you will not learn in a typical finance course. Again, these coupons expire in a month, and we are already 2 weeks in, so get your copy today. Okay, so 1 year after the release of TensorFlow 2, what do I think? Well, I think the general theme of this lecture is that it's okay, but it's not excellent. And unfortunately, being just okay today is not good enough when there are other tools gaining momentum very quickly. Firstly, let me start with what I like about TensorFlow 2. I like the fact that it makes creating neural networks very easy. This is 100% thanks to using the Keras API as the standard. If I have some idea I want to test, Keras is the easiest and fastest way to check the results without having to write a whole bunch of code. Unfortunately, on the topic of speed, that's where TensorFlow 2 starts to show its weakness. TensorFlow 2 has a feature called eager execution. This takes care of one of the major obstacles that students had when learning about TensorFlow and Theano. Creating neural networks used to happen in 2 parts. The first part involved creating a computational graph. In this stage, you would only state how the inputs are related to the outputs, but not actually compute any values. In the second part, you would use your computational graph to compute values. TensorFlow 1 implemented this using an abstraction called the session, which unfortunately confused a lot of people. In my opinion, Theano had a much nicer and cleaner interface. So this is where you have to decide whether the pros outweigh the cons. Sessions are gone, that's good. But now TensorFlow is very slow, that's bad. It's worth noting that the motivation behind eager execution was to make TensorFlow more like PyTorch. Well, PyTorch already has this behavior, and it doesn't need to make any sacrifices in performance. So in trying to become more like PyTorch, TensorFlow actually became worse than PyTorch. Another annoying aspect of TensorFlow that's been carried over from the version 1 days is that it's constantly being updated with breaking changes. So at this point, TensorFlow 2.3 is the latest version, which means that, since I made my course 1 year ago, TensorFlow has made major changes 4 times. This is good in the sense that TensorFlow developers are hard at work with the goal of making a better product. But this is bad in the sense that, if you always want to be using the latest and greatest, you will be spending a lot of time simply updating syntax instead of doing more meaningful work. So how about PyTorch? You may assume that PyTorch is more complicated than TensorFlow because TensorFlow uses Keras, which is very simple. However, you have to remember that this only applies when you are not doing anything interesting or customized. In my opinion, exploring new ideas and concepts is easier in PyTorch compared to TensorFlow because it's the correct level of abstraction. In PyTorch, it's easy because you're using the same tools you're always using. In Keras, it's hard because you need to use more obscure tools that you don't normally use. So now let's talk about the newcomer, JAX. Many people who are on the Google side are now using JAX instead of TensorFlow. So what is JAX? Very roughly, you can think of JAX like Google's low-level deep learning library that also works with GPUs and TPUs. When I first started my deep learning courses, a lot of beginners would complain that Theano was too difficult. Well, as it turns out, Theano was pretty much the correct level of abstraction. You'll find that JAX is very reminiscent of Theano in terms of where it fits on the spectrum between high-level and low-level. For example, if you want to build an RNN in JAX, you would make use of the scan function. This is the same as how we built RNNs in Theano. So for those of you who hated Theano, well, unfortunately for you, that's what is necessary to implement these things. It'll be interesting to see over the coming years whether JAX becomes the main library that we associate with Google rather than TensorFlow. Yet another popular approach that has emerged in recent years is Julia. Julia is an entirely different language than Python. Most commonly, people talk about how Julia is faster than Python. Just like with JAX and TensorFlow, Julia has libraries that implement neural network layers, as well as automatic differentiation. Now, it's important to remember that these are just tools. Just because you have a favorite tool doesn't mean you have to throw away all your other tools. Of course, I still use TensorFlow too. It's super easy to implement an ANN, CNN, or RNN in very few steps. That being said, usually I'm not trying to do something that easy. To give you an example, I was looking into replicating the code from my deep reinforcement learning course, which was originally in TensorFlow 1 and Theano. In PyTorch, I got it working almost instantly. In TensorFlow 2, I'm still trying to work out some bugs, and on top of that, it's an order of magnitude slower than PyTorch, TensorFlow 1, and Theano. So overall, I think TensorFlow still has its uses. If you want to do something very simple in Keras, TensorFlow 2 is fine. If the thing you're writing happens to be fast in TensorFlow 2, then TensorFlow 2 is fine. But it's not easy to tell what's going to be fast and what's going to be slow until you try. Otherwise, PyTorch or even JAX, which is still experimental, might be better options. Let's also not forget that a majority of researchers are now using PyTorch, and many companies are also moving to PyTorch. So if you are looking to join a lab or move to the industry, then PyTorch is probably the safest bet.